So I apologize for the confusing notes that I may have done yesterday. Let's take some fresh notes here on 6.3. It's the second day that we're graphing radicals. We're going to pick up right where we left off on the worksheet. But before we do that, let's understand that a radical function, a radical equation, looks like this. Y equals a square root of x minus h plus k. Right? You don't really have to, just write this down right here. Y equals a square root x minus h plus k. Now we should know that a causes a vertical stretch, a vertical compression. It also tells you if it's opening up or down, kind of similar to the quadratic functions. The a value tells you if it opens up or down, and if it's vertically stretched or compressed. The h and the k value, the h value will tell you where you shift left or right, and the k value tells you how to shift up or down. And you always think opposite on h because of this minus sign. Okay, you always think opposite of what you see. H will always be subtracted from x inside parentheses, and a square root is a form of parentheses right here. So h is inside the square root being subtracted from x always. So if I give you one of these equations and I tell you to graph it, how should we do that? What are the steps to doing that? Here they are. Now I know we wrote down some steps yesterday of identifying h and k, but I think these three steps might be a little more simple to follow. Step one, box in the function, leave out h and k. So you're boxing in y equals a square root of x, and you're leaving the h and k out of the box. Okay, so I always actually draw a box around this, leaving out h and k. Step two, graph the boxed function, and in parentheses right here say no h or k. So pretend that this is not here. So let me actually put a box right here. Wait a minute. We pretend that this is not here, and you would just graph that function y equals a square root of x, and you make an xy table, you come up with some coordinates. That's step two. And then step three is to shift your points according to h and k. Now remember, whatever h is right here, you think opposite, and k, you take it for what it is. The h value will determine whether you're moving left or right. The k value will determine whether you move up or down. And as a matter of fact, kind of like when we did parabolas, the vertex was the coordinate hk. Right here, it's not a vertex, but the coordinate h and k is equally as important, because the coordinate hk is your beginning point on the square root function, the beginning point of the square root function. It starts at that point and it shoots off in one direction. But anyway, those are the three steps I would like you to consider. Step one, box this in, leaving h and k out. Step two, graph this boxed function with xy table, with getting coordinates, x and y coordinates. And step three, shift your points, shift your coordinates according to your h and k. Shift your points according to h and k? Where? Ute. Shift ute. Niet. What? Okay. Yeah. Shift your. I'm sorry. Typo. Your. Shift your points according to h and k. You know what? You could even do this. Shift points according to h and k. Right? Sorry about that typo. Anyways, let's move on. Go to our worksheet, and I think we stopped right here on the last one on the bottom right side of our front page. And that's where we had a different a value other than 1. We had the 2 as the a value, and we also had 1/2 as the a value. And you know what? We might as well, since we're calling this like part of our notes, we might as well compare it with the original parent graph, y equals the square root of x. So let me start with this original parent graph. We already know the coordinates. What would a coordinate be for this y equals the square root of x? 0, 0, because when you do the square root of 0, you get 0. What would be a nice number to take the square root of? 1, right? When you take the square root of 1, you get 1. That's why you get the coordinate 1, 1. How about the next nice perfect square number? 4. So you go 4 on the x, 1, 2, 3, 4. 2 on the y because the square root of 4 is 2. And last but not least, 9, the square root of 9 is 3. So 9 on the x, 1, 2, 3 on the y. There's your parent graph, y equals the square root of x. So what I want to do now is go to this one right here. Let's do this one in red. And again, you're supposed to box it in, ignoring the h and k. And right here, there is no h and k, so you're not going to be shifting anywhere. Okay? Let's create an xy table, an input-output table. And you're going to go with the same nice perfect inputs that work, the perfect square inputs. So if you plug in 0, the square root of 0 is 0. And 0, when you do the square root of 0, you get 0. And 0 times 2 is still 0. Okay. When I plug in a 1, let's do this. What is the square root of 1? 1. And then 1 times that new a value of 2. What's 1 times 2? 2. When I plug in the perfect square number 4, that gives me the square root of 4, but square root of 4 is 2. 2 times 2 is 4. Last but not least, the square root of 9 is 3. So let me input 9. Square root of 9 is 3. 2 times 3 is 6. So let's see how this new a value of 2 modified the coordinates. You still have this point right here, 0, 0. So I'm going to still put it there. But now you have 1, 2 instead of 1, 1. You now have 4, 4, which is up here. And you have now 9, 6, way up here. So as you could see, when you compare those red dots compared to the parent graph blue dots, what happened? It got vertically stretched. It got vertically stretched, right? So it used to be right here. If you stretch something up and down like this vertically, obviously, like if I grabbed this dot and I pulled it up, it ended up here. I vertically stretched it. Make sense? So that's what we call a vertical stretch. If your a value is greater than 1, it will be a vertical stretch when you compare it to your original parent graph. If your a value is less than 1, it's going to be a vertical compression. So what's a compression? It's like me taking this point and crushing it, right? Compressing it, making it smaller, vertically compressed. So you'll see that when we do this guy right here, let's do this one in green. When we do an input-output table for that guy, when I do the square root of 0, square root of 0 is 0 times 1/2 is still 0. When I do the square root of 1, that's 1, but 1 times 1/2 is 1/2. When I do the square root of 4, the square root of 4 is 2. 2 times half is 1. And when I do the square root of 9, that's 3, and 3 times half is 1.5. Am I going too fast? You guys following me? Understanding me? I hope.
Wait, I have a question.
So let's plot those points. 0, 0 is still right there at the origin. 1/2 would be 1 on the x halfway up right here. 4, 1 would be right here. And 9, 1.5, 1.5 would be right here. So as you could see, comparing the green dots with the parent graph blue dots, it got vertically compressed, right? A vertical stretch would be from this blue dot right here being stretched up to the red dot. That's what a vertical stretch, because the a value is greater than 1. And from the blue dot, the parent graph, to this new one, it's a vertical compression because of the a value being less than 1. Okay, let's flip this over to the backside. So on all these, it's say use an input-output table. I don't recommend that. Let's actually use the steps that we just jotted down in our notes. Step 1, box in the function, leave out h and k. Step 2, graph that boxed function, ignore h and k. Step 3, once you graph it, shift your points accordingly to h and k. So number 1 is the parent graph. We already have that on the front side. Let's take a look at number 2. Do we have an h and k to ignore? If you box it in, there is no h and k, so you don't even have to worry about a left or right shift anywhere. All you got to do is jump straight to your input-output table. Okay, so what number would be nice to plug into a square root? Start with the easiest number, what? 0. When you plug in 0, what's the square root of 0? 0, and what's 0 times negative 2? It's still 0. So there's one coordinate. Let's go to the next number. Next nice perfect square number to plug in would be what? 1, right? Because you could do the square root of 1. What's the square root of 1? 1. And what's 1 times negative 2? negative 2. Do you guys see how if I did have a h and a k, I would still ignore it? I would get these coordinates, and then later on I would shift according to h and k. But anyway, the next perfect square number I want to plug in would be 4. And if I plug in 4 right there, the square root of 4 is 2, and negative 2 times 2 is negative 4. And the last perfect square number I could plug into this 10 by 10 graph would be what? 9. And when I do the square root of 9, I'll get 3, and 3 times negative 2 is negative 6. So we're going to plot the point 0, 0. We're going to plot the point 1, negative 2. Plot the point 4, 1, 2, 3, 4, negative 1, 2, 3, 4. I think I got that right. And 9, negative 6 would be over here. So it starts here at the origin, and it shoots in this direction. So again, the coordinate on a parabola, the HK coordinate on a parabola is very important. It's the vertex. The HK coordinate right here on a square root is also very important. It's your beginning point. So since there is no h that's being subtracted to x, and there is no k that's being added or subtracted out here, it's a 0, 0. That's your beginning point. And that beginning point is very important, especially when you talk about domain and range. I've been forgetting to mention domain and range on all these. So what would your domain be on this guy? X equals what? Now remember, x, here's your x number line. This is the negative direction. This is a positive direction. Does this graph exist anywhere in the negatives? No, it starts right here at the x value of 0, and it goes in this direction when you're talking about x's. So what do you say? What starts at 0 and goes this way? X is what? Greater than or equal to. So let's not say equal to, let's say greater than or equal to 0. How about the range? The range are going to be your y values. And your y values are up and down. Is this graph anywhere up here in the positives? No, it starts at 0. Like I said, HK is very important. It's the beginning point. It starts at 0 and it's below. So what do we say? Y is what? Less than or equal to 0. And that's about it. That one was easy because it did not require any shift. Which one would you guys like to try? 6. Let's check out 6. What's step 1 right here? Box in the function. The y equals a square root of x. Leave out the h and the k. So let me do exactly that. I want to box in the function. Y equals negative 1 square root of x. And I'm leaving out the h and the k. And then I'm going to go to an input-output table. And I want to plug in some numbers that are nice for this square root function. So when I do the square root of a nice number would be 0. The square root of 0 is 0. Put a negative in front of it, it's still going to be 0. Do a 1 right there. Square root of 1 is 1. Put a negative in front of it, it will be a negative 1. I want to plug in a 4 right here. The square root of 4 is 2. Put a negative in front of it. So again, I'm plugging in a 4. I get out a negative 2 when you put a negative in front of the answer 2. Plug in a 9, another perfect square number. The square root of 9 is 3. Put a negative in front of it. That's negative 3. So we have the coordinate 0, 0, 1, negative 1, 4, negative 2, and 9, negative 3. Now, if you drew it like I just did, that's not my answer. So I kind of messed up right there. If you did do that, once you're done shifting according to h and k, you're going to have to put 2 x's on this one because this is not the graph I really want. What is the graph that I really want? I need to move each and every one of these coordinates, these nice coordinates that I just graphed, each one of these coordinates, I need to move them according to h and k. So my h value is what? Negative 3. You got to think opposite of what you see in here with the x value, right? Think opposite. The k value, you take it for what it is, which is positive 3. So the negative 3 on h means you're going to shift it 3 to the left. The positive 3 on k means you're going to shift it 3 up. So every single one of these dots, we're going to move them 3 to the left and 3 up. So if I go 3, 1, 2, 3 this way, and 1, 2, 3 this way, I'll have that coordinate right there. If I take this next one, 1, 2, 3 over, 1, 2, 3 over, I end up right there. if I take this coordinate 1, 2, 3 over 1, 2, 3, I end up right there. Wait, did I do that right? I think I did. And the last one, 1, 2, 3 over 1, 2, 3, right on that x-axis. So here's my actual finished product graph. It starts right here at the coordinate HK, that coordinate being negative 3, 3. And from that coordinate, negative 3, 3, it goes down and to the right forever. It keeps going down forever, keeps going to the right forever. So if you think about that beginning point and the direction it's going, it should be pretty easy to determine your domain and your range. What's your domain? X is it to the left or to the right of this beginning point, x value negative 3? It's to the right. So we're going to say x is greater than or equal to negative 3. Okay, and again, we are looking at this beginning point right here at the negative 3, 3. Now, it's in terms of y, the range. Does it have any y values above 3? Here's the y value of 3, the level 3. Is there any points above 3? No. Is there any points below 3? Yeah. So it's at 3. Y is at 3 or below. How do we say that? Y is less than or equal to 3. So there's your domain and range for that one. You should be able to describe the transformations, maybe not right now, but later on I'll be asking you to describe the transformations from the original parent graph to this new final product here. So the original parent graph used to start at 0, 0, and it would shoot up in this direction. So you would say this negative a value, or a value of negative 1, causes the parent graph to reflect over the x-axis, and then you shift it 3 units to the left and 3 units up. That's the full description of the transformation that it goes through to get to the final graph. Any other one you'd like to see? Number 3, 4, 3, 4, 3, 4, 3, 4, 3, 4, 5, 5, 3. All right, so what does step 1 say over here? Box in the function. Leave out h and k. So let's box it in. Here we go. Let's go for the input-output table. Give me some coordinates, guys. What do I plug in? Plug in 0. What do I get out? Square root of 0 is 0. Plug in 1. What's square root of 1? Plug in 4. What's square root of 4? Plug in 9. What's square root of 9? 3. Now, these are the parent graph coordinates, and we need to now graph them and then shift them according to our h and k. So I might as well identify h and k. What's your h value? 0. There is no number that's inside the parentheses, in this case inside the square root, that's being subtracted from x. There is no number. The only thing inside the square root is x. The k value is 5, so we know we will be shifting them 5 units up. So I do want to take this moment to let you know you could graph the parent graph coordinates and then shift them 5 up, or you could actually shift them 5 up right now from these coordinates to get your final coordinates before graphing. It's totally up to you, all right? So if you wanted your final result coordinates without graphing these original parent graph coordinates, you would shift 5 up, which would mean you would add 5 to all your y values of your coordinates. So your actual ending coordinates would be 0, 5, 1, 6, 4, 7, and 9, 8. Okay? Or you could graph them the way I will right now. 0, 0, 1, 1, 4, 2, 9, 3, and then shift those 5 units up. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So if you happen to graph that red one, you'd have to put 2 x's on it because the real one starts at the coordinate hk, 0, 5, and it shoots off up and to the right forever. So what's your domain here? X equals, no, not x equals, x is what?
Greater than 0, greater than or equal to 0.
Greater than or equal to 0. This is the beginning point, and that has the beginning point x value of 0. So what's your range going to be? The range is going to be what? Y is greater than or equal to that beginning point y value of 5. That's right. And that's about it. So you guys could do the last 3 right now in class, and we'll be done with this. I'm thinking of giving a kind of retake quiz, but with 2 of these graphs tomorrow. All right? So if you did poorly on that first quiz, tomorrow you get an A, it'll go back and change it to an A. If you got an A on the first one, get an A on tomorrow's, you have 2 A's. Your A will be even stronger. What do you think? Okay, so you could study your old quiz. All that stuff's going to be on there. And we're going to have 2 of these questions on graphing radicals.